when working with compounded periodically and continuously formulas, we're able to solve for the present value variable p. So within the first one, compounded periodically, the form is a of t equals p times the quantity 1 plus r over n to the nt power. And compounded continuously is a of t equals pe to the rt. So let's look at examples and solve for the present value. To get $600 after 2 years at 4% compounded quarterly. So this is a compounded periodically formula because it is given as quarterly or monthly or daily or weekly, annually, semi-annually, whatever. That's typically your tip-off. Versus continuously, we'll just say compounded continuously. So let's take what we know and label it. So A of t is going to be my 600 because that's how much I want to get. That's my future value. My time says right there 2 years. My r says it right there 4%. So just convert that to a decimal, so 0.04. And then my compounded period is quarterly. There are 4 quarters in the year, so we say that n is 4. So it's however many times it is within a year. And I don't know what p is because that's what we're solving for. So I'll take all of what I know, plug it into the formula up here, and solve for p. So I'm going to get 600 equals p, because I'm solving for it, 1 plus 0.04 divided by 4 to the n times t, and n is 4, and t is 2. So parentheses 2. And now I'm just going to do all the work in the parentheses and the exponent just to make it a little bit easier. So I'm going to get 600 equals p, and all of this in the parentheses and the exponents will work out to 1.082857. I'm going 6 decimals deep just to make sure there's no rounding errors. You can go a little bit further, but I wouldn't go too much shorter just because, dealing with money, you might be off by a little bit. Now, solving for p is easy because p is multiplying by this entire parentheses. So I'm just going to divide the entire parentheses over. So I'm going to do 600 over this. And when I do that, I'm going to end up getting 554.09 for my present value. And I'm rounding to 2 decimals because this is money, and typically you round to the nearest penny when it comes to money unless told otherwise. So my present value, the amount of money I have to start off with to get to $600 after 2 years compounded quarterly at 4% is this amount. Let's do it again. To get $800 after 3 years at 8% compounded continuously. So it says compounded continuously, so that means I'm going to use the compounded continuously formula, PE to the RT. So let's write out what we know. So A of t, our future amount, is $800. The amount of time that passes by is 3 years, and the rate is 8%, so 0.08. Now we just plug it into our form. So it's going to be 800 equals PE, again E is a number, to the RT, so 0.08 times 3. And here I'm just going to do E raised to this power just to make it a little bit easier on myself. So 800 equals P, which is going to give me 1.27125. And now I'm just going to take this in the parentheses, that's multiplying by P, and I'm just going to divide it over. So 800 over what's in the parentheses, which will give me $629.30 for my present value. So I need to start off with this much money in a compounded continuously account at 3 years and 8% to get to $800. Now let's do the last one. To get $1,000 after 2.5 years at 6% compounded daily. So again, we know it's a compounded period of daily, so 365 days in a year. So our future amount, A of t, is going to be 1,000. T is going to be 2.5 years. Our rate is 6%, so 0.06. And the compounded period says daily, so we're going to ignore leap year, and we're going to say it's 365. Now that we have everything we need, are given in the question, we can plug it into our formula to solve for P. So 1,000 equals P, 1 plus 0.06 over 365, there, raised to the 365 times 2.5. Again, I would like to do everything that's within the parentheses raised to the exponent just to have a simpler number to write. So 1,000 equals P times 1.16182. And now I'm going to take everything in the parentheses and divide it over. So 1,000 over 1.16182. And I'm going to end up getting $860.72 as the present value I need to reach $1,000 after 2.5 years at 6% compounded daily.